So I only have one slide, and what's interesting is I only have one piece of paper that's kind of started the whole project. And I'm happy to say you can't really read that piece of paper, but you don't see any fancy data schematics with arrows going all over the place like you might see in a typical data project. Before I start there, though, the first question I usually get about what we do and what my team does is we are enterprise analytics. We report into our planning services department. Our planning services department is responsible for developing the overall strategy for Mayo with all the leaders. We support that. And then also the operational plans behind that. And the reason we have an enterprise analytics team in that group is that it's a very data-intensive process. And our job is to make sure that the information is available for not only development of the strategy, but also execution. Well, one of our core strategies at Mayo Clinic is differentiating ourselves in the area of complex care, which is what these guys do every day. And so when they asked us to help us, it was a no-brainer to try to help them make sure they had the information that they needed in order to care for our patients. So that's what, in a nutshell, our enterprise analytics group does. The one thing that we don't do is we are not data warehouse developers. We're not expert in that area. Instead, we're expert in how to use data warehouses. And that's a big differentiation, and I think what Lisa started to describe. What we often find is that, and this title of this presentation is just perfect for analytics, is that things get lost in translation. We get lost in the data. We get lost in the terminology. Terms like big data, machine learning, artificial intelligence, and a whole bunch of other terms. They could be used freely in discussions, but they often don't have context or meaning, not something that's meaningful to these folks. And so that's what we do, is we turn that into some meaning. And the way we do that is really pretty simple. What we do is we get these guys from worrying around about data and technology, and instead we return them to their roots, which is scientists. They really have to think like a scientist, and it gets back to no scientist would start a research effort without a question or a hypothesis. And so we get them to stop focusing on the data, instead start focusing on the problem, and that's exactly what we did. Dr. Markovich turned us on to a book. It's called What Can You Learn from Elephants and Epidemics? Great title for a book. My favorite quote in that book is, "What if the idea is old to the creator, but new to others?" I think it's just a great quote because this is how most creative activity occurs. Most of the creative activity within each of our silos has been exhausted, but when you put a team together with these different perspectives and these different intersections, the creative process really starts. And so I want to thank him for turning us onto that book because I think we could all learn something from those diverse intersections and putting this type of team together in the first place. A little bit as we get into Code-M. Code-M's a poster child for what I just described. Dr. Markovic and Lisa had been focusing on data for years. As a matter of fact, they had amassed over 150 elements in a database, and they were trying to make sense of it. And the problem is it was a lot of data. It was a lot of the condiments in the refrigerator, but not really a meal. And so we got them to take a step back. And what's at the top of this one pager here is 5 questions. We got them to step back and say, what questions are you really trying to answer? And then from there, and back to the point that was made earlier, we asked them another question, which is, which of those questions would have the biggest impact on your patients? And they homed in on this question. Do we know what the best treatment is for a disease? And I remember this really specifically because we had Dr. Markovich at the board, and so I remember it really well. And he wanted to stress not necessarily the first or second stage. That's the protocol that most people already know. But really, how can we be sure that we're treating a disease when it's in its third or fourth disease when there is no protocol? And so that's what we decided to focus on. The next thing we did is we asked them specifically, forget about the 150 elements. And I think they were pretty ready to do that anyway, so it wasn't a big stretch. And we said, how specifically would you answer that question? Forget about the data, forget about the constraints, forget about how hard it is to capture this data, but just tell us, in a perfect world, how would you answer that question? What metrics or measures would you use? And what happened from that, and this is when I think probably Rob and myself, my team, knew that we were going to be successful, we got down to 15 elements. The really cool thing is that of the 15 elements, some of the most critical weren't in the 150. So we would have never gotten to where we are with that original list of 150 elements. And I think that's the key to this whole process of stepping back and really focusing on the questions first and deferring that discussion on data as long as possible. As a matter of fact, the harder the problem, the longer I would defer that question. Because that's what gets you to the innovations that we created with CodeM. The other thing that's critical, and I kind of alluded to it just a few minutes ago, is you have to build partnerships before you need them. It's just absolutely critical. And so one of those partnerships that we developed earlier is with PwC, and Rob is one of our partners. So when this problem came up, we were already at full capacity, like any analytics group is probably around the country. But we had friends that we trusted and we knew could get this done. And so with that, I'm going to turn it over to Rob, and he's going to talk to you a little bit more specifically about CodeM.